The next part of the video will cover a dynamic routing protocol called Open Shortest Path First, known as OSPF. Since we use IPv4 in the video, we'll use OSPF version 2. If you were using IPv6, you'd use OSPF version 3. We enter router configuration mode using the router OSPF 50 command. The 50 refers to the process ID, which is local to the router only. So other routers don't have to use the same process ID. They will need to be in the same area for this particular example. We'll just be using one area, and all of the routers will have to participate in area 0. So the first thing we do in router configuration mode is enter the router-id command. We'll give the router an ID of 8.8.8.8. This will be used later to determine the designated router and the backup designated router. If you don't configure the router ID, the router will choose the highest active loopback IP address and use that as its router ID. And if it doesn't have that, it will use the highest active interface's IP address on the router as the ID. So by using the router-id command, we can control the designated router election process. The reason for this default configuration is convenience. You don't have to configure the router ID. It will configure itself and then participate in OSPF. It's also a disadvantage if you do it that way, because then you don't have control over the ID itself or the designated router election process for OSPF. In router configuration mode, we could use the network command to advertise all of the networks that we have on router 1. Most of the video, we will be using the interface configuration for OSPF. So to enable the advertisement of the routes, we will actually enter the interface configuration mode of the Ethernet ports and enter the IP OSPF 50 area 0 command. And this is the command that advertises the IP address on the interface. So now that we have the router ID configured, we're going to configure the IP address on the Gigabit Ethernet 0/0 interface. So we go into interface configuration mode and enter the command IP address 10.10.10.4, 255.255.255.224, and this will give us 30 usable IP addresses in the subnet. And then we enter the no shutdown command. The other command we need in interface configuration mode is the IP OSPF 50 area 0 command. This command is what configures the routing protocol to advertise the subnet. We move back to the left side of the topology to enter back into dist 1. We're going to configure dist 1 to participate in OSPF. First, we'll go into global configuration mode to enter the router OSPF 50 command. Next, we'll enter the router ID 0.1.1.1 command to give it the router ID. Then we enter the interface configuration mode for Gigabit Ethernet 3/1, which is the port that connects to the central router. We enter the no switch port command to turn the port into a routed port, so we can assign it an IP address of 10.98.98.2, 255.255.255.252. Then we enter the no shutdown command and the IP OSPF 50 area 0 command to have this interface now participate in OSPF. Now we move back to the central router, and when it boots up, we'll start the configuration. So like with all the other devices, we'll begin by giving the router a host name and then entering line configuration mode to enter the logging synchronous command to keep our syslog messages looking clean. We enter the interface configuration mode for Gigabit Ethernet 0/0 to assign it the IP address 10.10.10.3, 255.255.255.224, followed by the no shutdown command to enable the interface. Now we enter the Gigabit Ethernet 0/1's interface configuration mode and assign it the IP address 10.98.98.1, 255.255.255.252. We enter the no shutdown command to enable the interface. And then we use the IP OSPF 50 area 0 command to have this interface also participate in OSPF. We go back into interface Gigabit Ethernet 0/0 to enter the IP OSPF 50 area 0 command to have this interface participate in OSPF. And then we'll actually go back into router OSPF mode by using the router OSPF 50 command. And then we're going to configure a router ID of 7.7.7.7. And now we can see our neighbor adjacency has gone from loading to full. And so now the central router and Area 51 are now neighbors. Area 51 has the 8.8.8, and then dist1 has the 0.1.1.1. So the central router right now has two different routers that it's participating in OSPF with. Now we can do some network connectivity testing by using the ping command on dist1 to try to ping the Gigabit Ethernet 0/0 port of Area 51. And then we can see the ping is successful, which means we have IP connectivity. When I use the show IP route command, we can see here that I have a route to the 10.10.10.0/27 network. So when I go to ping something in that IP network, dist1 knows about it, forwards it to the central router, and then forwards it to Area 51. For this next part of the video, we return to the Area 51 network, and we're going to do some network address translation configurations. First, we're going to do a static IP NAT configuration on Area 51. For this particular example, we have two static NAT translations we need to configure. So we use the IP NAT inside source static command. With this command, the first part of the command is the inside IP address. So in this case, it will be the speaker of the house's PC to what the outside host NAT translation IP address will be. In this case, it's 10.10.10.11. And now we have to configure a second static NAT translation for our other desktop, which is the higher ranking general's PC. So we use the up arrow to get the IP NAT inside source static command back. Then we modify the inside IP address to be the general's PC as the inside address, and then 10.10.10.12 for the outside IP address. Then we need to enter the interface configuration mode for port Gigabit Ethernet 0/0. This is the port that connects to the routers, and we need to enter the IP NAT outside command. Then we need to enter the port facing the desktops, which is Gigabit Ethernet 0/2, to enter the IP NAT inside command. And that will finish our static NAT configuration. So I use a show IP NAT translation command to show that the inside global addresses match up with the inside local addresses. Inside local is the port facing our desktops, and inside global is the post NAT translation IP address. And now I'll ping the IP inside global address for the general's PC, which is 10.10.10.12, to verify that we've got IP connectivity. Now we'll move back to this left side of the topology, back into dist 1, which is one subnet over, and then we're going to ping the inside global address, which is the outside IP address, part of the NAT configuration. And once we ping it, we can see that we have IP connectivity. I decided to change the host name of the Area 51 vault router to Vault 51. So now what we're going to do on the Vault 51 router is we're going to configure dynamic NAT translation with the port address translation. So the first thing we have to do is define a range of IP addresses that we can use in our NAT pool. In this case, we're going to use 14 NAT IP addresses in our pool. So we use the IP NAT pool command followed by the name of the pool. In this case, it's the executive branch. Then we have to enter the low range of the IP addresses followed by the highest IP address in the range. So in this case, it'll be .16 and .30. And then we use the net mask 255.255.255.240 to finish off the command and define our network translation pool. The next part of the configuration requires us to use an access control list to define the network that will be translated. So in this case, it will be the 192.168.77.0 network, which is the President's network, and then the 192.168.7.0 network, which is the Vice President's network. And we have to use a wildcard mask of 0.0.0.15 to configure our subnet. And then I use a do show IP access list command to verify the access list. And here we can see we've got our two permit statements with their wildcard bits displayed in the show output. And this confirms that we've configured our ACLs properly. So now that we have an ACL and an access list pool, we're ready to configure dynamic NAT translation with port address translation. So the command we'll use is IP-NAT inside source list 7, which is referencing our access list, followed by pool, and then executive branch, referencing the name of our NAT pool, followed by the overload command, which is what configures port address translation. Port address translation allows multiple hosts to use the same inside global IP address. So what that means, for example, if all the inside addresses were 192.168.1.2.3 and .4, they would all be represented on the outside by an IP address of 10.10.10.10, for example, followed by whatever port is used in the connection for the socket. And then those different port numbers allow the same IP address to be used for the NAT configuration. And then you can have 65,000 different ports. So theoretically, you could use the same IP address for those 6,500 connections. And then we also have a range of 16 of those to use, so 16 times 6,500 possible connections that we could have. And that's what makes port address translation valuable and why it was implemented to help use IPv4 addressing longer. A big problem of IPv4, of course, is running out of IP addresses. Network address translation and private network addressing were used to extend the life of IPv4. You could also argue that the static NAT configuration is more secure because over there's only the 2 IP NAT translations, where over here we could have thousands of possible connections, which could make the network less secure. And also an argument to be made that if you knew the static IP inside global IP address, that's less secure. So the argument more becomes just awareness of the potential security risks for each type of configuration. And then there's other things you can do to mitigate those risks. The last part of the configuration requires us to enter Gigabit Ethernet 0/0 to enter the IP-NAT outside command. The last part of the configuration requires us to enter the IP-NAT inside command on our sub-interfaces. So we'll go into configuration mode for each sub-interface and then enter the IP-NAT inside command. So first we'll use the interface Gigabit Ethernet 0/1.7 command to enter the IP-NAT inside command. And then we just use the up arrow, modify the subinterface to 1.77, enter the IP-NAT inside command to finish the configuration for dynamic NAT with PAT. To trigger the IP-NAT configuration, I'm going to ping the 192.168.10.100 IP address. So even though the ping was not successful, we go into the router, use a show IP-NAT translation command, and we can see the president's IP address of 192.168.77.7 was translated to 10.97.97.17, and it's using port 18. The Cisco Modeling Lab desktops are configured for secure shell connections by default. So what we're going to do now is try to secure shell into this left side network general PC, and it fails, but still we go in and to the router, do a show IP NAT translation, and now we can see the protocol type was a TCP connection, which was the SSH temp, using the same 10.97.97.17 address, but with a different port number, this time 57.850. And that's the translated IP address, and the outside local address was the address we were trying to secure shell into. So now we're going to return to dist1, and we're going to configure our inter-VLAN subnets to participate in the OSPF dynamic routing protocol. So the first thing we do is we go back into dist1, and then in global configuration mode, we enter the command router OSPF50 to enter router configuration mode. This time we'll advertise the networks in router configuration mode instead of interface configuration mode. To do that, we use the network command followed by the subnet that we want to advertise. In this first case, it's 192.168.1.0 with the wildcard mask of 0.0.0.255, followed by area 0 to finish the command. This will then advertise that subnet to all of the other routers participating in the OSPF area. Once we enter the command, we just simply use the up arrow and then modify the subnet to be advertised. So here I go in and change 192.168.2.0.3.0.4.0 with the same wildcard mask and area. Now we'll go back into our other OSPF routers and issue the show IP route OSPF command to show the OSPF learned routes on the router. And here on the central router, we've learned our inter-VLAN routes. So that's pretty neat. We can see these 4 different subnets were learned by OSPF. Their next hop IP is 10.98.98.2. So now we'll come back into area 51, and we'll use the show IP route OSPF command. Since this router is participating in the OSPF area, it also gets the routes to our inter-VLAN routes on the left side of the topology there. So next we're going to piece in VLAN 50, 60, 70, and 80 into the OSPF topology. So what we'll do here on dist1 is we'll configure the port channel to participate in the OSPF configuration. So we enter interface configuration mode for port channel 15, enter the IP OSPF 50 area 0 command. Then we'll move to dist2, enter the interface configuration mode for port channel 15 on dist2. Then we'll enter the IP OSPF area 50 command. So now this ether channel link is also participating in the OSPF. So now we're going to move into dist2 and configure the OSPF routing protocol version 2 on it. So we'll start by entering router configuration mode with the router OSPF 50 command, and then give it a router ID of 0.0.1.1. After that, we'll move into the sub-interfaces and enter the IP OSPF area 50 command. The first subnet we'll go into is interface Gigabit Ethernet 0/0.50. And then we enter the IP OSPF 50 area 0 command. And then we can use the up arrow, change the sub interface, use the up arrow, enter the IP OSPF 50 area 0 command for all 4 sub interfaces. And now these sub interfaces are also participating in the OSPF configuration for area 0. So now we'll go back into the central router and we'll do a show IP route OSPF command. And as you can see, now we've got all 8 subnets in our routing table for the central router. Now we'll jump over to the Area 51 router, do a show IP route OSPF command, and we can see that we have all 8 subnets in our routing table for the Area 51 router. This is what makes dynamic routing protocols so special, is because here on Area 51 we did a pretty minimal configuration, and now we have a pretty good routing table to the rest of the topology because we have this router participating in OSPF, communicating with the other routers to find routes on the network. This next section of the video is going to cover the upper left-hand corner of the topology. We're going to turn a router into a DHCP server, have another router use the IP helper dash address command. We're going to configure a switch for DHCP snooping and dynamic ARP inspection. So just like the other sections of the topology, I dragged out a switch and 4 desktops. Here I add a second router, and we're going to label it expansion 1. Then we'll move into the switch, label it snoop switch, and then we'll connect all of the desktops to the switch. We're going to leave the expansion 1 router alone until we configure this first DHCP network off of the snoop switch. The desktops on the Cisco Modeling Lab platform will pull a DHCP IP address automatically if they're on a subnet with a DHCP server. As I build a topology, I'm turning on the network devices. That way it takes some time to build the topologies, so you might as well have your network devices trying to boot up while you're building these topologies. So we're going to go ahead and turn on a few more virtual machines, core 1, core 2, branch 1 in the snoop switch. As your topologies grow, the performance and the speed of the virtual machine starts to suffer a little bit. You can see my CPU is pegged out at almost 100% there. And here we get a warning, high system load. So while these new network devices are booting up, we're going to go ahead and build the second DHCP topology. We won't do any configurations on the second switch, but we will configure the expansion 1 router to use the IP helper address to get to branch 1 for its DHCP configuration. We're going to turn our attention to the upper right-hand corner of the topology to the secure zone router. We're going to connect a switch to the secure zone router, and then 3 desktops off of the switch. Here we'll be applying some ACL concepts and showing off the Cisco iOS security features. This switch is going to be labeled secure switch. We won't do any configurations on it. So now we'll connect the secure switch to the secure zone router. We'll drag out 3 more desktops and connect them to our switch. We're going to label the desktops now. This first one will be SSH. This next one will be Telnet. And the last desktop is going to be IP. what we'll be doing here is blocking those types of traffic to those PCs. So we're going to block SSH traffic to the SSH PC. So now that we have our network devices powered on and our topology built, we're going to start with branch 1. We're going to give it its host name, and then we're also going to enter the logging asynchronous command in line configuration mode to keep our syslog messages looking clean, just like with all the other network devices we've configured so far. Next, we'll enter Gigabit Ethernet 0/0's interface configuration mode to give it the IP address 10.10.10.1, 255.255.255.224. And then we'll also enter the IP OSPF 50 area 0 command to have this router's interface participate in the OSPF dynamic routing protocol. We'll also enter the no shutdown command to enable the interface. And then real quick, we're going to go into the secure zone router. We're going to give it its host name of secure zone. Enter the logging asynchronous command in line configuration mode to keep our syslog messages looking clean. And then we're going to go into the interface Gigabit Ethernet 0/0, go into its interface configuration mode, and configure the IP address 10.10.10.2, 255.255.255.224. And then we'll also enter the no shutdown command and the IP OSPF 50 area 0 command to have this interface participate in the OSPF routing protocol. We also need to set the router IDs. So we're going to use the router ID 2.2.2.2 command in router configuration mode. We'll come back to the branch 1 router, and we're going to enter the router configuration mode with the router OSPF 50 command. And then we're going to give it a router ID of 1.1.1.1. There is a command called clear IP OSPF processes. When you make changes to a configuration, especially with the router IDs, if you change the router ID, you have to clear the IP OSPF processes, and then that will update your adjacencies and therefore updating the router ID. So now we got all of those syslog messages letting us know about our adjacencies. We've actually got 3 neighboring routers off of the same interface with this particular topology. Now that the secure zone router is participating in the OSPF area, it picks up all of the routes that are in the dynamic routing protocol. So we get this entire left side topologies subnets in our routing table. And so now we'll come to the far side here, VLAN 80, and then we're going to ping the interface of the secure zone router and the branch 1 router. And we can see here we're getting the responses. The more virtual machines we have here on our topology, our performance will suffer. So what I'm doing here is I'm just turning off a lot of these virtual machines during the initial configuration. That way when we're doing our commands, we don't have to wait as much. Once you get everything up and running, you can leave it up and running, but during the initial configuration, it helps to reduce the amount of nodes. So we'll keep a few on just for like testing, but we're going to turn a lot of these nodes off and then move on to the upper left-hand corner of the topology to do the DHCP configurations.